Okay, let's do this Doppler effect example. So you should pause the video and read the question. Think about this on your own a bit. Okay, let's draw this out. We always want to draw out these Doppler effect problems. So we've got here our fire truck. And let's say it's moving that direction. So there is V of, let's say, truck. Or we could call that, since that's the source of our sound waves, we'll call it VS. And then we've got our car here, moving in the same direction. Let's call that VO for observer, because that's who's going to be hearing the altered frequency. And they're both moving in the same direction. Okay, so remember our formula that we're going to use is our new frequency is the old frequency. So maybe we'll call this F0 and F1 times V plus minus VO for observer, V minus plus VS for source. Okay, so they didn't tell us here what speed to use for the speed of sound in air, so we're going to use 344 meters per second, which is a good rough number to use for the speed of sound in air. That's this number right here. Okay, now we got to figure out the pluses and minuses. So this guy is going 30. This guy is going 20 meters per second. I got to figure out whether to use pluses or minuses here. So the key is here's my listener or observer. Here's my source. Draw an arrow from listener toward source. Anything that we're moving in that direction, we would use a plus. So if either the observer or the source were moving from right to left, we would use the plus sign, either top or bottom. Anybody that's moving the opposite direction, we use their minus. So in this case, my arrow from observer to source goes to the left. Both the car and the fire truck are moving toward the right, the opposite of that arrow. So I'm going to use the minus on both top and bottom here. It usually won't be the same sign. Usually you'll have like a plus on top and a minus on bottom or whatever. It just depends on whether you're moving in the same direction as that arrow or the opposite. So in this case, our new frequency will be the old frequency. What is that? 440 hertz times 344 minus 20 over 344 plus 30. And then I just lied. That should have been minus 30. It's minus top and bottom here, because they're both moving in the same direction. Anything moving in this picture to the right is a minus. Anybody moving to the left would be a plus. Okay, and I've already worked this out. This is 454 hertz, approximately. And there's our final answer.